Hey everyone, welcome to another deep dive with us. Today, we are diving into a research study that's looking at a pretty amazing new way to pull CO2 right out of the atmosphere.
It's really interesting work.
And the secret weapon is microalgae.
Yeah. It's fascinating how this study brings together the best of both worlds, the raw power of nature with some serious chemical engineering.
Okay, so maybe like a quick refresher for anyone who hasn't been following this as closely as we have.
Yeah.
The latest IPCC report, it basically confirmed what we all already knew: we were in a climate crisis.
Definitely.
CO2 emissions are way too high.
Through the roof, yeah.
And our atmosphere is just overloaded with the stuff.
Over 420 parts per million, which, to put that in perspective, it's like, you have a bathtub and you fill it to the brim and then you try to squeeze in like a couple more gallons.
Yeah.
It's just not sustainable. And we're seeing the effects.
Right.
In our daily lives now.
Absolutely.
Think extreme weather, rising sea levels, the whole 9 yards.
Yeah, it's getting real out there.
It is. So people are scrambling for solutions. We've all heard about planting trees, but apparently that's not going to cut it.
Well, planting trees is great.
Oh, yeah, of course.
Don't get me wrong.
Yeah.
But even with like massive reforestation efforts,
yeah,
we're really only looking at capturing a tiny fraction of our emissions, maybe 3 to 6%.
Wow.
Plus, we need a ton of land to do that. An insane amount of land to make a real dent.
So that is where our microscopic heroes come in, the microalgae. Yeah. And these little guys, they are 10 to 50 times more efficient at capturing CO2 than trees are.
They are.
Plus, they don't need these vast forests.
Right.
And they produce all sorts of useful byproducts.
Yeah.
Biofuels, cosmetics, you name it.
There's a lot of potential there.
Yeah.
But we can't just rely on growing more algae.
Right.
We need to find ways to make the capture process itself more efficient.
So that's where this research study gets really interesting.
Yeah.
It's looking at how to combine microalgae with another method called amine-based absorption. I will admit, this is where I start to get a little lost in the weeds.
It's actually pretty straightforward. Amine solutions, they're basically chemical sponges that soak up CO2 from industrial sources. Think of it like capturing the smoke before it leaves a chimney.
Okay, that makes sense. But I've heard there's a catch, right?
Yeah.
Something about the process being like really energy intensive.
You got it. It takes a lot of energy to regenerate those amine solutions so they can be used again and again. It eats up a huge chunk of the energy, somewhere between like 57 and 70%.
Wow, that's a lot of wasted energy.
It is.
So how do the microalgae fit into all of this? Are they somehow replacing that heating process?
That's the gist of it, yeah. The researchers found a way to use microalgae to regenerate those amine solutions, which cuts down on the energy needed.
That's so cool.
Yeah, it's a really clever approach that takes advantage of a specific type of amine called triethanolamine, or TEA.
TEA? Fancy.
Well, it turns out that TEA is kind of a matchmaker. When TEA reacts with CO2, it forms bicarbonate. And bicarbonate is like a delicious feast for our microalgae friends.
So instead of heating everything up, we just let the microalgae have a bicarbonate buffet and call it a day.
That's a great way to put it.
But can any microalgae do this, or are we talking about like some special superpowered species?
Well, there's this particular strain called Xenodesmus acuminatus, and it's been a real rock star in previous CO2 studies.
Okay.
And the researchers found that it not only can handle bicarbonate, it actually thrives in higher concentrations of TEA when CO2 is present.
Wait a minute. I thought high concentrations of amines were supposed to be toxic to algae.
They can be.
What's going on here?
Well, that's the surprising part. It seems like the presence of CO2 somehow protects the microalgae from the potentially harmful effects of the TEA. It's all about finding the right balance.
Okay.
And that's exactly what the researchers set out to do in this study.
Okay. I am hooked.
Great.
Walk me through it. What did they actually do to figure all of this out?
So they started by putting Xenodesmus acuminatus through a series of tests, exposing them to different concentrations of TEA and CO2. And they wanted to see how much TEA the algae could tolerate before things went south.
So like a stress test for microalgae.
Exactly. And the results were, well, they were pretty surprising.
Oh.
The algae actually grew better at higher TEA concentrations when CO2 was around.
Interesting.
It seems like the bicarbonate formed by that TEA and CO2 reaction was providing them with like an extra boost of energy.
Hold on, I just want to make sure I understand this. We're saying that the microalgae actually did better in a harsher environment
Kind of.
As long as there was enough CO2 to go around.
It seems that way.
That's crazy.
It is quite remarkable. But there's a catch.
Oh, okay.
Remember those high amine concentrations we talked about earlier?
Uh-huh.
The ones that are used in industrial CO2 capture?
Yeah.
Well, regular microalgae, they might struggle to handle those.
Right, because too much of a good thing can be a bad thing. So how do we get around that? Do we need to genetically engineer, like, super algae that can survive in a TA-saturated world?
Not quite. This is where the concept of living biocomposites comes in. Imagine giving those microalgae, like, a little house to live in, a protected space where they can thrive even in those challenging conditions.
Okay, I'm picturing tiny algae apartments. What do these houses actually look like?
You're not going to believe this, but the researchers use something called loofah.
Wait, seriously? We're talking about fighting climate change with shower loofahs.
It might sound strange, but loofah actually has some amazing properties that make it perfect for this.
Okay.
It's got a large surface area for the algae to attach to. It's porous, so nutrients can reach the cells. Yeah. And it's cheap and sustainable.
I have to admit, that's pretty ingenious.
Yeah.
So we've got our microalgae. They're all cozy in their loofah homes.
Right.
What happens next?
Well, the researchers had to figure out how to get the algae to stick to the loofah. So they tested different binder concentrations, like trying to find the perfect glue to hold everything together.
Yeah.
They even used a decision matrix to pick the best binder.
Oh, wow.
Very high-tech stuff.
A decision matrix for algae glue.
Mm-hmm.
I love that they're bringing that level of precision to this. But how could they actually tell if the algae were happy and sticking properly to the loofah?
They used what are called SCM images, which are like super high-resolution photos that let you see things at a microscopic level. And these images clearly show the microalgae clinging to the loofah fibers, forming a stable biocomposite structure.
So you've got our microalgae all settled in their loofah apartments, glued together with the perfect binder. Yeah. They are ready to face the CO2 challenge.
They are.
What happened when the researchers actually put these biocomposites to the test?
Well, that's what we'll dive into in part 2 of this deep dive.
Can't wait.
So welcome back to the deep dive. Last time we left off with our intrepid microalgae all snug in their loofah homes, ready to tackle some CO2.
Yeah, they were ready to get to work.
Ready to get to work, exactly. So the researchers, they put these biocomposites to the test.
Okay.
And the results were, well, let's just say they were pretty impressive.
Okay, spill it. How much CO2 did these loofah algae powerhouses actually remove?
So they compared the biocomposites to a system where the microalgae were just floating freely in the solution.
Right.
And the biocomposites removed 2 to 4 times more CO2.
Wow. Those little loofah houses really made a difference, huh?
They did, yeah.
What was it about the biocomposites that gave them, like, such an edge?
It seems like the structure of the biocomposite provided a more stable and protected environment for the algae,
Okay.
So they could focus on gobbling up that CO2 without having to worry about getting tossed around in the solution.
That makes sense. So how did the researchers actually measure the CO2 removal? Were they just eyeballing it, or was there like some high-tech measurement system involved?
Oh, no, they were very meticulous. Yeah. They meticulously tracked the CO2 removal over a period of 28 days, refreshing the TEA solution every few days to keep those microalgae well fed.
Oh, nice.
And they even tested different CO2 levels to see how the biocomposites performed under a variety of conditions.
So they really put these biocomposites through the ringer, huh?
They did.
And they passed with flying colors.
They did. Although it wasn't a simple more is always better situation.
Yeah.
They found that both too much and too little CO2 could actually stress the microalgae out.
Interesting.
It was all about finding that sweet spot, that Goldilocks zone,
Yeah.
where the biocomposites could really shine.
So not too much, not too little, just right.
Just right, exactly.
I like that.
Yeah.
But even with these, like, incredible results, I can't help but wonder where all that captured carbon actually goes. Are we just accumulating a giant pile of CO2 somewhere?
That's a great question, and it leads to a really exciting concept called carbon capture and utilization, or CCU for short. And it's all about taking that captured CO2 and turning it into something useful rather than just storing it away.
Wait, so we can actually use that CO2 for something? Like, what kind of useful things are we talking about here?
Well, think biofuels, bioplastics, even fertilizer. Wow. The possibilities are pretty amazing when you start thinking about it.
Okay. I'm definitely starting to see the bigger picture here.
Yeah.
We're not just talking about, like, cleaning up the mess we've made, right?
Yeah, right.
We're talking about creating a whole new circular economy.
Exactly.
Where carbon isn't a waste product, but a valuable resource.
Exactly. And that's what makes this research so compelling, I think.
Yeah.
It's not just about mitigating the negative. It's about creating a positive impact.
Okay, this is all very exciting.
Yeah.
But let's get real for a minute.
Yeah.
Is this technology really scalable? Could we see, like, microalgae farms popping up everywhere, like little green oases sucking up CO2?
Well, scaling up any new technology always comes with its own set of challenges, right?
Of course.
And this study was conducted in a very controlled lab environment,
Right.
Transitioning to the real world is going to require a lot of work.
So we're not going to see algae-powered skyscrapers anytime soon.
Maybe not skyscrapers.
Yeah.
But there's a lot of research and investment going into scaling up microalgae cultivation.
Yeah.
For various applications. And carbon capture is definitely a hot topic.
Right.
So I wouldn't rule anything out just yet.
Okay. That's reassuring.
Yeah.
But I'm guessing there are still some hurdles to overcome before this technology can, really go mainstream. What are some of the, biggest challenges that you see?
Well, one of the key challenges is making sure these biocomposites can thrive in different climates and environments. What works in a lab in Thailand might not be so successful in the Sahara Desert, for example.
Right. One size doesn't fit all when it comes to climate solutions.
Exactly.
So we need biocomposites that are, adaptable and resilient to a wide range of conditions.
For sure.
What else?
Durability is another big one.
Yeah.
We need to make sure these loofah structures can hold up over time and resist degradation.
Right.
And, of course, we need to make sure the whole process is economically viable.
Yeah, of course.
So you need to be able to grow, harvest, and process the microalgae efficiently and affordably.
It makes sense. We can't have a climate solution that's only accessible to the wealthy, right?
Exactly.
Or that breaks the bank to implement.
And it's not just about the economics,
Right.
We also need to consider the social implications.
Oh, of course.
Engaging with communities and stakeholders is essential to make sure this technology is deployed responsibly and equitably.
So it sounds like a balancing act.
It is.
Finding the right mix of scientific innovation, economic viability, and social responsibility. But also sounds incredibly hopeful.
There's definitely reason for optimism. If we could overcome these challenges,
Yeah.
Microalgae-powered carbon capture could be a real game changer in our fight against climate change.
This is all so fascinating. We've covered a lot of ground, but I'm curious, is there any other interesting research happening in this field,
Oh, absolutely.
Are there other avenues being explored that could lead to even more, groundbreaking discoveries?
For sure, yeah. Researchers are always pushing the boundaries. For instance, they're looking at different types of amines that could be even more efficient at forming that bicarbonate feast for the algae.
Okay.
They're experimenting with different support materials and microalgae strains to optimize the biocomposite design.
It's amazing to think that we're still just scratching the surface of what's possible.
I know.
Who knows what other breakthroughs are just around the corner.
Exactly.
But for now, let's take a breather and shift gears a bit. In part 3 of this deep dive, we'll explore the broader implications of this research and what it means for the future of carbon capture. All right, welcome back, everyone, for the final part of our deep dive. We've been talking about this really cool research using microalgae to capture CO2.
Yeah, it's been quite a journey.
It has. From tiny algae to these giant climate challenges we've got.
Right.
With a pit stop at those loofah-powered carbon capture systems.
We've covered a lot, that's for sure.
We have. But I think it's important to, zoom out now and consider how this research fits into the bigger picture, of climate action.
Yeah, definitely. It's easy to kind of get caught up in the excitement of a new discovery.
Totally.
And lose sight of the overall goal.
So where does this microalgae technology fit in? Is this the solution to all of our problems? Or is it just one piece of a much larger puzzle?
It's definitely not a silver bullet.
Right.
No single technology can solve climate change.
Yeah.
We need a multi-pronged approach that combines emissions reduction with carbon removal. Think of it like, a toolbox. We need a diverse set of tools to tackle this problem.
So it's we've got a hammer, a screwdriver, a wrench, and now we can add microalgae-powered carbon capture to our climate action toolbox.
Exactly. And this particular tool, it could be especially useful for industries that have a really, really hard time cutting their emissions.
Okay.
Things like cement production, steel manufacturing,
Right, heavy industries.
Yeah. Those sectors, they rely so heavily on fossil fuels.
Yeah.
And it's like a huge challenge for them to find cleaner alternatives.
So for those industries that are, maybe struggling to kick their fossil fuel habit,
Right.
this microalgae technology, it could be a way to at least capture some of that CO2 before it escapes into the atmosphere.
Yeah, you can think of like putting a filter on a smokestack.
I like that analogy.
It's a way to mitigate the damage while we figure out how to truly decarbonize our economies.
So it's not an excuse to just keep burning fossil fuels,
Sure, of course not.
recklessly. It's more like we're buying ourselves some time while we figure out how to truly transition,
Yeah, to a more sustainable future.
Yeah, exactly.
Yeah.
But even if it's not the ultimate solution, it's still a huge step forward.
It is.
I am curious though, how long before we actually see this being implemented on a large scale, Are we talking years, decades?
It's really hard to say for sure.
Yeah.
Moving from the lab to the marketplace always takes time.
Right.
But the good news is there's already a lot of momentum building.
Okay, so what are some of the encouraging signs that you're seeing?
Well, for starters, there are already several companies out there, investing heavily in microalgae cultivation for a whole variety of applications, including carbon capture.
Oh, cool.
And governments around the world are starting to recognize the potential of this technology.
Yeah.
And are starting to put money into research and development.
Awesome. So the wheels are in motion.
They are, but there are still some major roadblocks along the way, for sure.
Yeah, I bet. What are some of the biggest challenges that need to be addressed before this technology can truly go mainstream?
Well, we talked about the technical challenges, right?
Yeah.
Optimizing the biocomposite design, making sure they're durable, things like that.
Yeah.
But there are also economic and social considerations that are just as important.
Absolutely. It's not just about the science. Right. It's about making sure the technology is affordable and accessible, and it doesn't, create new problems while it's trying to solve the old ones.
Exactly. We need to bring the cost of production down.
Right.
Make sure it's sustainable over the long term.
Right.
And that it benefits everyone, not just a select few.
Yeah. Equity is so important.
Absolutely. And that means, engaging with communities.
Yeah.
Addressing any potential environmental impacts and being transparent about the risks and the benefits.
It sounds like a huge undertaking.
It is.
It's not just about building a better loofah, it's about building a better future,
Yeah, you could say that.
It can feel kind of overwhelming.
It is a daunting challenge for sure. But it's also an incredible opportunity.
I like that.
And it's not something that scientists and engineers can do all on their own.
Right.
It's going to take a collective effort with everyone playing their part.
So what can we do? Us as individuals, besides listening to podcasts like this one, obviously.
Right.
How can we contribute to making this, microalgae powered future a reality?
Well, staying informed is a great first step.
Okay.
The more you understand about the science, the challenges, the opportunities, the better equipped you'll be to advocate for change.
I like that.
Talk to your friends and family about this. Share articles on social media. Write to your elected officials.
That's a good point.
Every voice makes a difference.
And don't forget about the power of, the purse strings. Supporting companies and organizations that are investing in this technology.
Right.
That's a really concrete way to show that you believe in its potential.
Absolutely. And never underestimate the power of small actions.
Yeah,
Often something as simple as choosing sustainable products or reducing your own carbon footprint.
It all adds up.
It all adds up, for sure.
Okay, so I think it's time for us to resurface from this deep dive.
Yeah.
But before we go, I want to leave you with one final thought.
Okay.
This microalgae research is a great reminder that even when we're facing, these huge, overwhelming challenges,
right,
there's always hope. If we can harness the power of nature, combine it with human ingenuity, and just work together towards a common goal, we can really create a future that is not only sustainable, but thriving.
I agree. The solutions are often in the most unexpected places.
Yeah.
Keep exploring, keep asking questions, and never lose sight of the fact that we have the power to shape the future.
That's a great note to end on.
Yeah.
And that's a wrap on another deep dive. Until next time, stay curious and keep exploring the world around you. You never know what amazing discoveries are out there.